So 1.2, here we go. So this is another one, the part of the board I'm blocking, you're going to want to jot down. Next time I see you, there's a 16-point quiz that has 2 questions. I'll tell you the 2 questions and then we'll see what you can fill in from your knowledge you possess, and I'll help you fill in the gaps. Question 1 is, into what 3 groups is the number line separated? So in a minute, we'll talk about the real number line. There's 3 groups of numbers on the real number line. That'll be question 1 for notes, question 1 for quiz. Next time I see you, 3 points. What 3 groups is the number line separated? Question 2 is to name and describe all the kinds of numbers that we talked about in class. So there's going to be 6 kinds of numbers that we'll talk about. A name, a description, and then we'll set about looking at what kind of homework problems do they generate to practice the knowledge that we now possess. But does anybody know what 3 parts is the real number line separated into?
Positive, zeros, and negatives.
That is correct. So I usually do spelling for half. So positive, I'll start you with the POS. The vowel sometimes messes people up. Anybody confidently know this vowel?
I.
It is an I. And then the TIVE part is okay. So there's positive numbers on the real number line. There's negative, so I'll spot you the NEG that people can spell, and then the vowel can be a problem. A. TIVE. And then you can just put the symbol for 0, that's fine. 0 is not positive, 0 is not negative, 0 is in a category all of its own. But there's 3 groups on the real number line. In the room, people, you can see my number line. At home on the camera, people can't see it because the camera can only capture certain areas. But there's positive numbers to the right, there's negative numbers to the left, there's 0 to separate. But 0 is not part of either club. 0 is just one of a kind in its own club. Question about that? Then there's 6 types of numbers. 7th grade, we talked about probably 4 of the 6. I don't know that we talked about all 6 of these. If you're an algebra runback, you would have talked about all of these last year. When you get to Algebra 2 someday, these are all going to run back right at you. It's sort of funny, Algebra 1 and Algebra 2, the years that I teach them both, the yesterday lesson from Algebra 1 would be like the today lesson of Algebra 2. And the yesterday lesson of Algebra 2 does the same thing. It's like, it's the same 2 lessons, just in a different order in the 2 books. Algebra 2 starts off with all of this information and then goes on to what you already learned about. So try to store this somewhere where it's still there in a year and save you some bother. Prime numbers is not what I'm hunting, although that's not bad. Composite numbers is not a thing I'm hunting, although that's not bad. Even numbers, not what I'm hunting. Odd numbers, not what I'm hunting, although those are kinds of numbers. Other than those, does anybody know a kind of name of a type of group of numbers?
Real number?
There are real numbers. So I did this in like a little bit of an outline form. You don't have to put it in an outline form when you do it. But real numbers is the biggest category of all. Real numbers are all the numbers that you know. Unless you've done outside research on your own, outside of school, and have ever heard of a thing called imaginary numbers or complex numbers, which you probably haven't because most people are not off on their own researching imaginary or complex numbers. Real numbers are literally every number you've ever seen or known or heard of. Anybody know another club of numbers?
Positive?
We're not going to go back to positive, negative, 0, but that's certainly those are types of numbers. There's an R group that I don't know if you'll know unless you've had Algebra 1 before. There's an I group that I don't think you'll know unless you've had Algebra 1 before. There's another I group from 7th grade that everybody knows. It's just a matter of retrieval.
Integers?
Integers. INT, and then every other vowel is an E. INTEGERS, integers. I'm doing this little indent thing because, again, who's real? Which numbers are real? All of them. Then the reals get split into one or the other of these groups. You can't go into both of these groups. Every real number are these or those. Most of the ones you think of are these, but some numbers are those, but we don't have the category yet. Then if it fits into this category, it's possible it fits into an integer list. Okay, but the way I'm diagramming this, if something's an integer, it is automatically this, and it's automatically real. When we get to this category, how it's like way indented, if you're in category number 5, you are guaranteed also to be part of category number 4, which also puts you in category 3, which puts you in category 2, which puts you in category 1. Okay? If you're in category 6, you're also in category 1. That's why I like diagrammed out the way I diagrammed that. Does anybody know another kind of number?
Rational.
Rational is this one, which makes its counterpart be irrational. So every real number is either rational or irrational. Most of the numbers you deal with are rational. Anybody know another group? It's a W group we talked about in 7th grade. This is a C group that we talked about in 7th grade, but it has a synonym name that starts with an N. Memory to these.
Whole.
There are whole numbers, W-H-O-L-E, whole numbers. That's true.
Counting.
Counting numbers, true. Let's watch another letter. It's a famous baseball movie. It's old though. It's old like me. Not as old as me, but old enough I saw it when I was your age.
Natural.
Natural. Robert Redford hits a home run at the end and like all the lights explode because he hits it off the... It's a good baseball movie.
Wait, this was is natural or part of?
Natural and counting are synonyms. Like we call you Quentin and we call you Q. It's the same, you're the same guy. You know, natural and counting. It's the same, two names for the same. Does anybody know what any of these lists are about? What makes something be rational? Who are the integers? Who are the whole numbers? Who are the natural numbers, counting numbers? Who are the irrationals? Anybody remember what any of that is? What are they for? How do you know who's who?
A whole isn't like a half. It's just a normal 1 or 2.
Yeah, 1 and 2 are whole numbers. Let's name some other whole, other than 1, 2, some other whole numbers. 4 is?
5.
3, 5. You're forgetting a real important one.
10.
0.
0 is a whole number. The whole numbers start with 0. So whole numbers, to describe them, start with 0, 1, 2, 3. You don't want to list them all because you go forever. How do we show that to our list?
Dots.
Dot, dot, dot. So whole numbers, when we do this quiz, next time we see you, and I say describe these numbers, whole numbers, the title gets you a point, and then if you go 0, 1, 2, 3, dot, 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 I'll give you a second point. Forget the dot, 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 I'll go half point. If you forget 0, I'd give you nothing because that's super important. The whole numbers start with 0. Memory trick for that you could use if this helps you. What are homonyms? You know what homonyms are? The words that sound the same, but they're not the same word, they're spelled differently. So like H-O-L-E is a homonym for W-H-O-L-E. They're both whole. Wholes look like zeros. So wholes include the 0 who looks like a hole in the ground, but wholes include 0 and they go up from there. How do you think the integers are different then, that they're like they're a bigger club? Because all of these whole numbers are also integers. How could the integers like be all of those and then grow it up a little bit?
They have like fractions.
They won't have fractions. That wasn't a bad thought, but no.
I think it was more than talking
No, exponents is what you're thinking of.
They'll have negative.
Include the negatives. So on the number line that we can see in the room, or this little baby number line I did right here, these are all the integers. It's not just the positive whole numbers and 0. It's also the negative versions of all those same numbers. So to do integers, it's like -2, -1, 0, 1, 2. But this list goes on forever, backwards and forwards. So we need a ... to start our list. We need a ... to finish our list. And they're going forever both ways. When you do the negative side of this list, do them in the order they are in the number line. Like, don't go -1, -2, the way you go +1, +2. Recognize the negative numbers count oppositely. So count up from -2 to -1 to 0 to 1 to 2. Let's go down to counting or natural. How could you cut the list, do you think? The whole numbers are these. The counting numbers are only some of those. Who might you cut?
Fractions.
We already cut fractions a long time ago. We'll double back to this answer. Rational can be fractions. So I'll give you that answer away. Rational are numbers that can be fractions. If we cut out all the fractions and decimals and whatnot, we're left with integers. Cut out the negatives, we're left with wholes. Cut somebody out and you're left with counting or natural.
Is it just the negatives?
No.
You cut out the 0.
Cut out the 0. 1, 2, 3, go forever. That's our counting numbers. To remember that, I would just think, picture like a small child that you know, and they come to your house and somebody's talking to them and saying, do you know how to count? And they're like, yeah. You're like, go ahead, count. Where do they start? 1, 1, 2, 3, 4. They go as high as they go. But you don't count starting with 0. You count starting with 1 from the time that you're a very little person. So counting numbers, natural numbers, 1, 2, 3, forever. Don't forget the forever symbol. Whole numbers, 0, 1, 2, 3, forever. Integers include the negatives, go forever both ways. Rational can be fractions. Real is all the numbers that you know. Irrational, an explanation that's too obvious for me to give you a point. What could you say for irrational, but I won't give you a point for it?
Can't be fractions.
Can't be fractions. But I'm not going to take that. Okay, so rational, they can be fractions. Irrational, while it's true that they can't be fractions, I'm not going to give you a point for that. What I will do for irrational is I'll let you take a different approach. Let's talk about decimals here. If we do irrationals, the decimals do something a little bit weird. You know what happens to decimals for irrational numbers? Does anybody know an example of the most famous irrational number? It's a pretty crazy number. Somebody said it, I think, pi. Yeah, why is pi like a really pretty wild, crazy number? It's the only number that you kind of know that's like this.
Goes on forever.
Yeah, it goes on forever and it never ends, but there's other things that never end.
Like
It also never repeats. So if we go irrational, the decimals never end and they never repeat. And I'll take that for an answer. If we wanted to talk about rationals then, rational means that the decimals could either repeat or they could, it doesn't matter, either way is fine. Like think 7th grade chart, decimal chart. We encountered like 0.3 with the bar on it. What that bar meant is that this was never gonna end, but it did repeat, so that's rational because it repeats. We did the 7ths. The first day we did the 7ths. It felt like it was never going to end or repeat, but eventually it did. It's 1, 4, 2, 8, 5, 7, 1, 4, 2, 8, 5, 7, 1, 4, 2, 8, 5, 7. It doesn't end, but it does repeat, which makes this rational. Pi, it never ends and there's never a repeating pattern. It eventually has to repeat little sequences because you run out of numbers, but it's 1, 4, 1, 5, 9, 2, 7. So, and then it goes forever. This one got followed by a 4. This one got followed by a 5. So just because it had ones didn't mean it repeated. It didn't do the whole pattern again. If I had time to fill the whole board with pi, would we get another 14 somewhere on my board? Yeah. But this 14 got followed by a 1, and maybe next time that 14 got followed by a 6 or something else. If we wanted to fill all the paper on Earth with pi, would you get this full sequence eventually rolling around again?
Yeah.
Probably, yeah. But this 7 maybe is followed by an 8, and the next time you found it, it's followed by a 4 or something else. There's never a true repeat. Even though there is some temporary matches, there's never like a full way to put a bar on it. The other thing that is irrational that you're not super familiar with is pi is irrational, and you don't have to say this for the quiz, but a lot of square rooty numbers are irrational. If you try to ever grab a calculator and do the square root of 2, you'll get a thing that fills your whole screen, and it's like pi. It won't end, it won't repeat. Even if your screen went on forever, you'd never get a pattern to it. Question about that? Okay, so one game they're going to play with you in the homework is they're going to ask you, what kinds of numbers are these? So if I just say 8, how many of the groups is the number 8 in? 5 out of 6. It's everything except
6.
irrational. Agreed. 8 is accounting, which automatically makes it whole, integer, rational, real. 8 is in all 5 of those clubs. 0, is that also in all 5 of those clubs, or is it in fewer of the clubs? Fewer. 0 is not.
Rational?
No, it is rational.
Counting.
It's not counting because it got cut out of that list. But 0 would be everything from whole up. -6.
5.
Fewer than 5.
Rational.
It's rational.
Real.
It's real.
It's not an integer.
It is an integer. Because if we kept going with this list forever, -1, -2, you run into -6. That would be everything from integers up. How about -6.5?
Still 3.
4.
Nope.
2.
Rational.
2. Which 2?
Real. Rational and real.
Rational and real. We could make this a fraction, and everything is real. But it's not any of those, because decimals and stuff got cut out. Square root of 7.
Irrational.
Irrational, because if I give you weird square roots, those are irrational, and everything is real, so 2. Square root of 9, though, is different, because the square root of 9 you can do, it's 3. So the square root of 9 is 3. How many lists does 3 go into? 5 lists. Everything from counting up. 3 is like 8. It's in almost every list. How about 2/3?
Rational.
Rational, because it is a fraction. Real, because everything's real. 12/3 is a little different, because 12/3 really is 4. And 4 is like 3, is like 8, is in 5 of those lists. Question about that? Bell's going to ring. I think it cut me off, but let me finish this real quick. The other part of the homework is that show something is rational. So if I had to show 4 is rational, put 4 over 1. 0 is 0 over 1. 0.7 is 7 over who? 10, because it's in the tenths place. This is 123 over 1,000, because it's in the thousands place. This, don't put 3 and 2/10. That is not a fraction. That's a mixed number. Put 32 over 10. This isn't a fraction, that's a mixed number. Do you remember how to make a mixed into a fraction?
You like multiply
2 times 6,
and then plus
add 1, 13 over 2 would do it. And the other quick thing in the homework is using coordinates. It's just numbers to locate points. So if I say, who has a coordinate of 2? You'd say F. What's the coordinate of B?
-2.
That's going to be a little bit of the homework. The syllabus will have the numbers. It's the next page of assignment. If you really, really need to know, it's on page 10. It goes 1 to 36. So it'll be coordinates and some show it's rational and what groups is it in. That's it.
Thank you, Mr. Rizio.
I think